The universe is a vast and mysterious place full of wonders that we have yet to understand. From the smallest subatomic particle to the largest galaxies, everything in cosmos is connected in ways that we are only beginning to fathom. So, what if I told you that most of the universe is made up of something we can't see or detect, something that scientists call dark matter and dark energy? What if these unseen and undetected invisible forces are pulling the strings behind the scenes, controlling the fate of galaxies and the ultimate destiny of the universe? In this episode of Veracity, we will try to unveil all of these questions and more in a simplest way possible. So without further ado, let's dive into it. In the early days of astronomy, scientists believed that the universe consisted only of the visible matter that we can see with telescopes. However, as technology improved and our understanding of physics deepened, astronomers began to realize that there was much more to the universe than meets the eye. They discovered that most of the universe is made up of two mysterious substances called dark matter and dark energy. According to current estimates, dark matter makes up approximately 27% of total matter energy density of the universe, while dark energy makes up about 68%. This means that only about 5% of the universe is composed of the ordinary matter that we can observe, such as stars, planets, and galaxies. Now, what is dark matter? Dark matter is a hypothetical form of matter that does not interact with light or any other form of electromagnetic radiation. It cannot be seen or detected directly, but its presence can be inferred from its gravitational effects on visible matter. In fact, dark matter is thought to be 5 times more abundant than visible matter in the universe. So if this substance present in our universe cannot be seen or detected, then how scientists have found out the existence of this thing? The search for dark matter. Well, despite decades of research, scientists have not yet directly detected dark matter, as it does not interact with light or any other form of electromagnetic radiation. However, through multiple experiments and hypotheses, scientists have confirmed the existence of these unknown material. One way that scientists have studied dark matter is by observing the rotation curves of galaxies. In a galaxy, the visible matter, stars, gas, and dust is concentrated in the center, while the dark matter is distributed throughout the entire galaxy. As the galaxy rotates, the gravitational pull of the visible matter should cause the stars in the outer regions to slow down. However, observations have shown that the stars in the outer region of galaxies are moving at nearly constant speed, indicating that there must be additional matter present that is providing a gravitational force. This additional matter is believed to be dark matter. Another way scientists have studied dark matter is through the observation of gravitational lensing. When light passes through the gravitational field, its path is bent. By observing the way that light from distant objects is distorted by gravitational pull of nearby galaxies, scientists can map the distribution of dark matter in those galaxies. Scientists have also used computer simulations to study the properties of dark matter. These simulations create virtual universes with different amounts and types of dark matter and allow scientists to observe how the dark matter behaves in different scenarios. Finally, scientists are using a variety of experimental techniques to search for dark matter directly. One such experiment is the Large Hadron Collider, the world's largest particle accelerator, which is designed to create and study high-energy collisions between particles. Another experiment is the Dark Energy Survey, which uses a 570 megapixel camera to capture images of galaxies in the southern hemisphere. By studying the way that light from these galaxies is bent and distorted by the gravity of dark matter, scientists hope to learn more about its properties. Although none of these experiments has yet detected dark matter, they are helping to narrow down the possible properties of this elusive substance. The ultimate fate of the universe. The discovery of dark matter has led to questions about the ultimate fate of the universe. Will the expansion continue forever? Will it eventually slow down and reverse, leading to a big crunch as the universe collapses back in on itself? Or will it accelerate to the point where the galaxies are ripped apart and universe is torn apart in a big rip? Despite the efforts of scientists around the world, the mysteries of dark matter remain unsolved. What is dark energy? Imagine that universe is like a balloon that is constantly expanding. Now imagine that there's a force inside the balloon that is pushing it to expand faster and faster, even as it grows larger and larger. This is the mystery of dark energy. Dark energy is even more mysterious substance than dark matter. It is a form of energy that permeates all of space and is causing the expansion of the universe to accelerate. Unlike dark matter, which exerts a gravitational pull on visible matter, dark energy appears to push visible matter apart. Discovery of dark energy. Scientists discovered the existence of dark energy through observations of distant supernova. In the late 1990s, two independent teams of astronomers were studying the light of distant supernova in order to measure the rate at which the universe was expanding. They expected to find that the expansion was slowing down due to gravitational pull of visible matter in the universe. However, to their surprise, they found that the expansion was actually accelerating. This observation led scientists to propose the existence of dark energy as an explanation for the accelerating expansion of the universe. One such technique is the study of cosmic microwave background radiation, which is the leftover radiation from the Big Bang. By studying the fluctuations in this radiation, scientists can learn about the structure and composition of the universe, including the presence and properties of dark energy. Another technique is the observation of large-scale structures of the universe. By mapping the distribution of galaxies and cluster of galaxies, scientists can study the way that dark energy has influenced the growth and evolution of these structures over time. Scientists are also using a variety of experimental techniques to study dark energy directly. These include experiments that are designed to measure the expansion rate of the universe with greater precision, as well as experiments that are designed to study the properties of dark energy in the laboratory. The nature of dark energy. Despite the fact that dark energy makes up about 68% of the universe, we know very little about it. Some scientists believe that it may be related to the vacuum of space, which is not truly empty, but instead contains fluctuations in energy that could contribute to dark energy. Others believe that dark energy may be related to the concept of cosmological constant, a term that was first introduced by Albert Einstein in his theory of general relativity. According to this theory, dark energy could be a property of space itself, causing it to expand at an accelerating rate. Its existence is inferred from its effect on the expansion of the universe, but its properties remain a mystery. Understanding dark energy is one of the greatest challenges facing modern cosmology, and scientists continue to work towards unlocking its secrets. In conclusion, the enigmatic forces of dark matter and dark energy are some of the biggest mysteries of modern science. They represent a new frontier in our understanding of the universe, one that is filled with uncertainty and excitement. Despite years of research and countless theories, we still do not fully understand their nature and how they interact with the rest of the universe. But we do know that they are responsible for much of what we observe in the cosmos, and that they hold the key to understand the ultimate fate of the universe. So, as we continue to explore the depths of space, let us never forget that the greatest mysteries of the universe may be hiding in plain sight, just waiting to be discovered. So, if you find this video interesting, give it a thumbs up, subscribe, and I will see you guys in the next one. Peace out.